Alright, in this video we are going to go through the 7778 assignment, the first of two assignments. So there's two parts. We have pages 401 to 402 and page 407. I also wanted to do this just to make sure that all of you were able to get onto the online textbook if you don't have your textbook at home. Hopefully most, if not all of you, have your textbook with you. But if you don't, I posted on the classwork tab the online textbook link, so you can click on here, open that up, and then it should open you right to the textbook. Some of you might get, let me see if I can get to there. Some of you might get this page. If you do, there's going to be a drop-down menu, and then you'd go to Common Core High School. So again, drop-down menu, Common Core High School, and then hit go, and then select the Algebra 1 textbook. All right, so in this assignment, we are working on, again, pages 401 to 402 for the first part. So over here it has go to page. That's probably the easiest way to get there. You could navigate by chapter and then look at the individual sections, but I'm going to go to pages 401 to 402. So I'm just going to scroll down here to 401, and there it is, and then go to the looking at the bottom here, that's 402. So it's got the entire section, and it's separated by section. So this is all of 7.7. So there's 401 right here, and then 402. And you are able to save these. So I'm just going to save this to my desktop here, page 401, and page 402. All right. So I want to go through these. So let's go ahead and start with the first one. I'm going to need some more space for these. So let's just say, give me a second here. I'm going to open up something to write on. All right, here we go. So page 401, numbers 3 through 13 odd. So I'm going to start with number 3. And looking at number 3, it says factor the polynomial. So we do have to factor this polynomial, and it is a binomial, m squared minus 49. Now remember the difference of two squares pattern? Let me put that up here. The difference of two squares pattern. That is when you have a squared minus b squared. It factors into the quantity a minus b times the quantity a plus b. And again, like I said in my lesson video, you could switch those two around. You could say a plus b times the quantity a minus b, because the commutative property of multiplication says you can switch the order in which you multiply. It doesn't change the result. But we are going to have to use this quite a bit in this section, the difference of two squares pattern. So on this one, right away, it's the difference of two squares pattern. This is m squared minus, this is a perfect square. This is 7 squared. This is m squared minus 7 squared. So this is a squared minus b squared, where a is now replaced with an m, and b is replaced with a 7. So in here, we're going to replace a with an m, and b with a 7. So we have a is now m, minus b is now 7, times the quantity a, which is now m, plus b, which is now 7. That's it. That's what this binomial factors into, because it is the difference of two squares. And you could FOIL these back together to double check your answer, but that is the correct answer. All right, it's number 5. On number 5, again, we have the difference of two squares pattern, but it's a little bit more complex. So this one is 64 minus 81d squared. So 64, that's 8 squared. 8 squared. Minus 81 is 9 squared. But I'm going to write this as a quantity. It's not just 9 squared, because I've got d squared. So I'm going to say the quantity 9d squared, because that would give me 9 squared d squared, which is 81d squared. Well, now this is a squared minus b squared, where a is 8 and b is 9d. So in the pattern here, you replace a with 8 and b with 9d. So this becomes, instead of a, I'm going to put 8, minus, instead of b, I'm going to put 9d, times the quantity, instead of a, I'll put 8, and instead of b, I'll put 9d. And again, you could double check this by FOILing it out. 8 times 8 is 8 squared, or 64. The outside and inside will cancel out, because you're going to get a positive 72d and a negative 72d. And then the last two will give you a negative 81d squared. So that is what we started with, so that's correct. My daughter's been crying a lot today. Sorry if you hear crying in the background through most of this video. All right, number 7. Number 7 looks a little bit worse. Some bigger numbers here. 225a squared minus 36b squared. So now we're using a and b, which might make this a little bit more confusing, but it's still the same idea. Can we write this as a quantity squared minus a quantity squared? Well, 225. Some of you will look at that and go, I don't know if that's something squared. So you could always take out a calculator, and if you want to know if it's a quantity squared, you just do the square root. So you take the square root of the value. I can find my square root button on here. It's 15 squared, but I don't know where my square root button is. If you can find my square root button on here, let me know, because I don't see it. All right, so anyway, you could take the square root. Let me pause this for a second and take a look. All right, so it is hiding in my menu right here. So second and then square root. So anyway, the square root of 225 is 15. So 15 squared is 225. So on this one, 225 is 15 squared. So I'm going to write this as the quantity 15a squared, because that'll give me 15 squared, which is 225, times a squared, which is a squared. I've got my minus symbol here, subtraction, and then we've got 36b squared, so the quantity 6b squared would give me 36b squared. So I can write this as a quantity squared minus a quantity squared, and that factors into the first quantity minus the second quantity times the first quantity plus the second quantity. I'm not going to say a minus b, a plus b, because I've already got a's and b's in this one, so I don't like that the authors used a's and b's, but it still works. So we've got 15a minus 6b and 15a plus 6b, and that is the factored form of that original binomial. And there we go. All right, moving on. We had to go through 13, so let's go to number 9. On number 9, it says use a special products pattern to evaluate the expression. Well, all of these are the difference of two squares, so that's what that special product pattern is. It's the difference of two squares pattern. So for number 9, we've got 12 squared. Let's use a different color. Let's go to green. 12 squared minus 9 squared. So this still is a squared minus b squared. And I know some of you just used your calculator and you did 144 minus 81. But this one says we have to use a special product pattern. And when you get really good at this pattern, this becomes easier to do than thinking of those numbers squared and then finding the difference of those big numbers, because what this is going to turn into, if this is a squared minus b squared, and we factor this into a minus b times a plus b, this becomes 12 minus 9, so there's your a minus b, times 12 plus 9, there's your a plus b. Well, those are pretty easy to compute. 12 minus 9 is 3, and then 12 plus 9 is 21. And 3 times 21, that's much easier to do than 144 minus 81, in my opinion. 3 times 21 is 63. And that would be the same answer that you would get if you were to evaluate 12 squared, which is 144, minus 9 squared, which is 81. You still get 63. But doing it this way, you're dealing with much smaller numbers. All right, moving on to number 11. And in case you're wondering, yes, you do have to do it this way because the directions say we have to use a special product pattern. All right, number 11, 78 squared minus 72 squared. So again, there's my a squared minus b squared, so this is going to factor into a minus b times the quantity a plus b. So this one, yeah, you're adding and subtracting some fairly big numbers, but that's much nicer than doing 78 squared minus 72 squared. I have no idea what those are off the top of my head. That would take a while to think about. These, they're not too bad. Let's see what happens with this. 78 minus 72 is just 6, so that one is easy. Adding these, you get 144 plus 10, so that is, 140 plus 10 is 150. And then multiplying 150 by 6, yeah, it's not great, but it is much easier to evaluate that than 78 squared minus 72 squared. So 6 times 150, you can do 6 times 15 and then tack on a 0. So that's going to be 15, 30, 45, 60, 75, 90, and with an extra 0 is 900, and that is the result. So I don't mind if you want to pull out a calculator just to double check yourself and do 78 squared minus 72 squared. That's fine. You should still get that same answer, but please, please, please use that difference of two squares pattern. All right, so moving on, number 13. Number 13, we've got 53 squared minus 47 squared. 53 squared minus 47 squared. So we've got a minus b, 53 minus 47, times the quantity a plus b, so 53 plus 47. 53 minus 47 is 6. 53 plus 47 is 100. And that's easy to compute. That is 600. Again, if you feel like taking out a calculator to verify this, I can show you that it is correct. 53 squared minus 47 squared, and you do get 600. All right, so we had 3 through 13 odds. There's all of those, and then 41 is the last one on this page. So I'm going to put 41 right down here. All right, so on 41, let's scroll down here. Oh, that's on my other page. On 41, you have an equation that you're going to be seeing quite a bit in Algebra 2. It's talking about the effects of gravity on some object. So just by looking at this equation, I'm thinking, okay, it's starting at 25 feet, and it's losing some height based on gravity. This is 16 feet per second per second. So this is gravity's pull on that object. We're going to be seeing that a lot as we move forward. But let's look at this one. It says, while standing on a ladder, you drop a paintbrush. The function represents the height of the paintbrush t seconds after it's dropped. After how many seconds does the paintbrush land on the ground? So this would have some implications for if you're dealing with physics or anything with astronomy and gravity. All right, so after how many seconds does the paintbrush land on the ground? Well, it says y is the height in feet. And when it lands on the ground, your height is 0 feet. So I'm going to plug in a 0 for y. So that's really the trick of this one. I need to plug in 0 for y because 0 is the height when that paintbrush hits the ground. And then we have to solve this equation. So in order to solve this, this is the difference of two squares. We have 5 squared minus 4t quantity squared. So I'm going to factor this. So I have 0 equals 5 squared minus the quantity 4t squared. And then I get 0 equals 5 minus 4t times the quantity 5 plus 4t. So now we're going to apply that zero product property, and this is what we've been working on for a couple of lessons now. So I have 0 equals a product. Remember, in order to get out a 0 when you're multiplying two factors together, one of the factors must equal 0. So either 5 minus 4t equals 0, or 5 plus 4t equals 0. And we solve both of those. So we get, when we subtract out the 5 here, we get negative 4t equals negative 5. Divide both sides by negative 4, we get t equals 5/4, which is 1.25 seconds. Or for the other one, if we subtract off the 5, we get 4t equals negative 5. Divide by 4, we get t equals negative 5/4, or negative 1.25 seconds. So the question here is, how long does it take for that paintbrush to hit the ground? So you can't have negative time. This is what's called an extraneous solution. It does not make sense for our given problem. So the only solution that would make sense is the 1.25 seconds. So that is what my answer is going to be. I'm going to write this in a sentence since it's a word problem. I will say the brush will hit the ground after 1.25 seconds. There we go. All right, so that's it for that first page. Then we have to go to the, or for the first part of the assignment, then we have to go to the second part of the assignment, which was on page 407. So on this part of the homework, we are going to be factoring by grouping because we have 4 termed polynomials on 3 through 9 odds. So To factor by grouping, like I said in my lesson, you group the first two and the last two terms together. So in every single one of these questions, group the first two and last two terms together. And then what we're going to be looking for in those groups of terms is greatest common factors. So what is the greatest common factor between x cubed and x squared? That is going to be an x squared. What remains when you factor out an x squared? Or in other words, if I were to redistribute this into those parentheses, I should get back to that x cubed minus x squared. So x squared times x is x cubed. X squared times negative 1 is negative x squared. So that's how you go about factoring out the greatest common factor and writing what is left for each of these pair of terms. On the next one, the greatest common factor is a 2, so I'm going to put plus 2 because it's a positive 2. And then what remains when you factor out a 2, on this one, it's going to be an x plus 1. I just realized I made a mistake, but I want to talk about it. This is supposed to be a plus, x cubed plus x squared. So I missed my plus sign right here, which I knew that had to be a mistake. Otherwise, this would not be factorable because I did not get the same quantity inside of the parentheses. So the problem was supposed to be a plus, which makes this a plus. Because x squared times x is x cubed. X squared times positive 1 is positive x squared. Now I've got the same quantity in both of these large terms right here. I've got an x plus 1 right here and an x plus 1 right here. So we've got another greatest common factor, and in this case the greatest common factor is an x plus 1. So I'm going to factor out x plus 1 from each of these large terms. And then what would I have to multiply all of this x plus 1 by to get this first large term? Well, I'm missing an x squared from the x plus 1, so x plus 1 times x squared would give me that whole first term. For the next large term, I need a plus 2, a positive 2, so I need to put plus 2 because if I take all of this x plus 1 and distribute it, I should get both of those terms back, and x plus 1 times 2 is x plus 1 times 2, or 2 times x plus 1. All right, so there we go. That is the beginning step of factoring a 4-term polynomial. Now we always want to make sure that we're factored completely. So are you able to factor either of these binomials any farther? And at this point, if it's not the difference of two squares, that's the only method I've taught you so far for factoring binomials. So if it's not the difference of two squares, and if there's not a greatest common factor, it's factored completely. In Algebra 2, you're going to learn the difference in sum of cubes patterns, but in here we're not going to deal with those just yet. So this is the factored form, and even if I gave this problem in Algebra 2, that's the factored form as well. There's not the difference of two squares, there's no greatest common factor, so we can say that's factored. We're done. Okay, let's go on to number 5. On number 5, we'll go through that same process. So the first step, group them, the first two and the last two terms. Then we need to look for the greatest common factor. In this one, the greatest common factor is z. What must be in this first position that when you multiply by z, you get this first term, and that is a 3z squared. What must be in the next position that if you multiply by z, you'd get this term, and that's a positive 2. On the next two terms, the greatest common factor is a negative 4. The first position in this binomial is going to be a positive 3z squared, because negative 4 times 3z squared gives me that negative 12z squared. And the last term is going to be a plus a 2, positive 2, because negative 4 times 2 is negative 8. All right, again, we've got that greatest common factor. 3z squared plus 2 is here, and 3z squared plus 2 is there. We can factor out 3z squared plus 2. And what remains when you factor out 3z squared plus 2 from this large term? You've got a z. So if I were to redistribute this onto z, I'd get that first large term. On the next one, I need a minus 4, a negative 4, because multiply 3z squared plus 2 by negative 4, you would get that term back. So again, double check, make sure you can't factor any farther. There are no greatest common factors here nor there, and this is not the difference of two squares, so that is my answer. All right, do the same thing for the next two. So factor out the greatest common factor, figure out what would have to remain, factor out the greatest common factor, and figure out what would have to remain. And then they both have the greatest common factor x plus y, so we can factor that out. And what remains is an x plus 8. and that is the answer. Again, if you've got the order switched, so if you had the quantity x plus 8 times x plus y, that is still correct. So you can flip the order of any of these factors on any one of these problems. You still got it correct. All right, on this one, factor out the greatest common factor of the first two terms. What remains is an m minus 3. And of the next two terms, the greatest common factor here is an n. And then we would need an m minus 3. Now we've got a greatest common factor of m minus 3. And then the first position here would have to be m to get this m back if we were to redistribute m minus 3, and then plus n to get that n back if we were to multiply it by m minus 3. And there is my answer. All right, so that was 3 through 9. We just have two more little sections of problems to go here, 12 through 22 evens and 23 through 27. I realize this is a lot of homework, but I really needed you to practice this a lot, so I apologize for giving you so much homework, but please hang in there. Thank you for all of you that are putting in the time and the effort. All right, so going on to the next little section of problems, I'm going to start with number 12, and I have 12 through 22 evens. All right, Microsoft Paint, there we go. 12 through 22 evens coming right up. So these say factor the polynomial completely. So right in the directions there, they're giving you a hint, since it says factor them completely, that once you factor the first step, you're probably going to be able to factor some more. And on a lot of these, if not all of these, that will happen. So give me a second here. I'm going to write all these problems down. All right, so on this first problem in this little section here, number 12, we've got a binomial. So the first thing I'm going to look for, and you should always look for when you factor polynomials, is a greatest common factor. So on this one, both 36 and 4 are divisible by 4. So I'm going to factor out a 4. And then both of these are divisible, the a to the fourth and a squared are divisible by a squared. So I'm going to factor out 4a squared. That is my greatest common factor. And what would remain after factoring out 4a squared? 36a to the fourth divided by 4a squared is going to give me 9a squared. In other words, if I multiply 4a squared by 9a squared, I would get 36a to the fourth. 4a squared times what would give me this? Or in other words, if I take this term and divide out 4a squared, I would get a negative 1. All right, so again, we factored out the greatest common factor, but we need to factor completely. We always want to factor completely, not just because the directions tell us to do so. So here, this is actually, this piece right here, this binomial is the difference of two squares. The difference of two squares pattern. So what we need to use here is the difference of two squares pattern. A squared minus b squared equals a plus b times the quantity a minus b. So I'm going to write this as an extra step here. If you're starting to get used to this, where you can go right to the factored form, that's great. I'm going to write this as the quantity. So we've got the quantity 3a squared, which is 9a squared, minus 1 squared. So there's my quantity squared minus my other quantity squared, like a squared minus b squared, and then it's going to factor to a minus b times a plus b. Unfortunately, again, we're dealing with a in here, so I don't really want to say that too much. So I've got my 4a squared out in front. The factored form of this binomial is my first quantity minus my second quantity times my first quantity plus my second quantity. And there we go. So this is the factored form. There are no more greatest common factors. There's no difference of two squares. This is the factored form. That's my answer. And again, if you've got these factors mixed up, that's okay. You'd still get the same answer because of the commutative property of multiplication. So it's still correct. All right, number 14. This is a trinomial. So a trinomial, if it's factorable, factors into the product of two binomials. To get an m squared, thinking about FOIL, I need an m and an m, because when I multiply the first two, I get m squared. The outside and the inside two are going to have to multiply together, multiply and then add together to give me a negative 5m. And the last two have to multiply to negative 35. So start thinking of some numbers that multiply to a negative 35. So I'm thinking 5 and 7, 5 and -7, -7 and +5, but those are not going to combine give me that -5m. So I've got to try something else. So let's think of some other possibilities. So let's see. 1 and 35 won't work. It's not divisible by 2, or nor 3, nor 4. We tried 5. That didn't work, so we got to keep on going. Um, So 7, 5, 35, nope, 35, and no, definitely not 35, 12, 13, 14, 15, 15 would be 30. So this one, there are no two numbers that are going to be multiplying to -35. Like I tried 5 and 7. So those multiply to -35, but when you go to try to double check this, you get m squared plus 7m minus 5m minus 35. So m squared plus 7m minus 5m minus 35. When you combine those two middle terms, m squared plus 2m minus 35, you don't get that -5m. You can try all the possibilities. I just took a second and thought of all the different possibilities, and none of them worked, which means this is the first one you've seen that is unfactorable. Unfactorable. And that is a possibility. That is actually what I'm going to say is my answer on this one. It is unfactorable. The directions say factor it completely. You can't factor it. If you just circle the original trinomial, I'll still give that to you as well. But we can't factor it. All right, so let's go to number 16. On number 16, again, we've got a trinomial, but this one, do we have a greatest common factor? We always want to check that first. It'll make our lives a lot easier when we go to try to factor. So right away, I see all three of these terms contain the same variable, so I can factor out d. What about the numbers? 6, 21, 15? Well, 6 is divisible by 2, 3, or 6. 21 is not divisible by 2, 15 is not divisible by 2, so we can rule out 2. 15 is not divisible by 6, nor is 21, so we can rule that one out. So what about 3? 15 is divisible by 3, and 21 is also divisible by 3, so we could take out the 3 as well. And on this one, I see that I have a negative leading coefficient, so what I'm going to do is factor out a -3, and again, all of them have the same variable, so I'll factor out a -3d. Now, what remains when you factor out -3d? It's going to be a 5d squared from the first term, a negative, because I need to multiply a negative times a negative to get that positive, so a -7d on the next term, and the last one's going to be a +2, because -3d times +2 is -6d. All right, now I'm going to keep that -3d carrying down throughout my problem, and now I've got to factor this trinomial right here, this 5d squared minus 7d plus 2. I have to factor this trinomial into the product of two binomials. So 5, that's a prime number, so I know I need 5d and d in my first two positions, because 5d times d is 5d squared. 2 is also a prime, so the last two have to multiply to 2. So either this has to be a +1 and a +2, or a +2 and a +1. But here's the issue. We need to get out a -7. So I'm sorry, I can't use two positives. I need two negatives. A negative times a negative gives me a positive, but I need them to combine to give me a -7d. All right, so just thinking of my possibilities, 5d squared, -10, that's not going to work out, so I need a 1 here and a 2 here. So just to double check that, 5d times d is 5d squared, 5d times -1 is -5d, then I have a -2d, so that combines to give me that -7d, and then -2 times -1 is +2. So this is the factored form, and that is the answer. All right, so let's go on to number 20. On number 20, this is a trinomial. Right away, again, we want to think of greatest common factors. So all of these terms are divisible by 8. Again, if you're not sure, you could take out your calculator, do 72 divided by 8, you get 9. So yep, they're all divisible by 8. So we're going to factor out an 8. And what remains is a t squared plus t minus 9. Now we need to factor this trinomial. All right, so I'll carry down the 8. That trinomial will factor into the product of two binomials. My first term is t squared, so I need a t and t. I need to get a negative 9, so I'm thinking 3 and 3 or 9 and 1. Those are my only options. But look here, I need to combine them to get a positive t. So if I try negative 3 and positive 3, well, that's actually the difference of two squares pattern. My middle term would cancel out. I wouldn't get a plus t. So that's not going to work. And the only other option I have is a negative or positive 9 and a negative or positive 1. So it has to be a 9 or a 1. Or I could try a 1 here and a 9 there, but that's going to give me t squared plus t minus 19. That'll give me a negative 18 in the middle, so that's no good. So I could try the 9 here and the 1 there, but that's going to give me a positive 18 in the middle, so that's no good. So you could try all the possibilities, but ultimately you are not going to be able to factor this one. So we factored out the greatest common factor in the first step, but this trinomial is unfactorable. The trinomial in the second step is unfactorable. However, because we were able to at least factor out a greatest common factor, that is considered factored. So there's no way to factor any farther, but this 8 times the quantity t squared plus t minus 9 is our answer. And just in case you're not watching the video, but you're just looking at my answer key, I want to put that this trinomial is unfactorable. So maybe I should make a bigger note here for anyone that's just looking at this. All right, so my note says we were able to factor out the 8. The resulting trinomial here is unfactorable, but we were still able to obtain a new slightly factored answer. So unlike on number 14, we were unable to change our original trinomial in any way. On this one, we were able to change our original trinomial by factoring out an 8. So this still is factored form. We just can't go any farther. All right, number 22 is a 4-termed polynomial, so we are going to factor this one by grouping, but again, you want to look right away. Are there any greatest common factors among all 4 terms? And the answer to that is no, because we have an h here, where there's no h there, so no, there's no way to take out a greatest common factor. So we group them, the first 2 and last 2 terms. We take out a greatest common factor from each group of terms. So here, the greatest common factor is h squared. What would have to remain is an h plus 4. And here, the greatest common factor is negative 25, and we need an h plus 4, because negative 25 times h is this term, negative 25 times 4 is negative 100. Now we've got the greatest common factor in the 2 large terms here. They both have an h plus 4 in them, so we can factor out h plus 4. And what would remain is an h squared minus 25. Now this one is not the answer right here, because we still have this guy right here. This is the difference of 2 squares pattern. Let me just put that on here. The difference, this is the difference of 2 squares pattern. Keep factoring. So if you can keep factoring, keep factoring. All right. Beautiful. All right, let's keep moving. So on this one, we have to keep going. This is a squared minus b squared. This is a squared minus 5 squared. So factor. That was my son yelling. All right, so on this one, we've got a squared minus b squared, h squared minus 5 squared. So we have h plus 4 from this first factor. H plus 4. And the second factor will factor into h minus 5 times the quantity h plus 5. And one more reminder, you could switch the order of these factors. So if you had h plus 4 times h plus 5 times h minus 5, that is still correct. All right, so there we go. All right, the very last little section of problems here is 23, there we go, 23 through 27. On these, we are solving. So it says solve the equation. So these have the equals 0. So when you go to solve an equation, you need them to equal 0 when we're going to factor, because then we can apply the zero product property. So on number 25, it's not equal to 0. So that will be your first step, is to get it equal to 0, so that we can factor it and use the zero product property to help us solve. All right, so looking at number 23, the first step, because it's a trinomial, well, really with any factoring, we're looking for a greatest common factor. This one has a greatest common factor. You can factor out n. 5n actually. So when you factor out 5n, what remains is n squared minus 6n plus 8 equals 0. Again, because you could redistribute that 5n to get that 5n cubed. The 5n here would give you a negative 30n squared, and that 5n times 8 is positive 40n. All right, so we need to factor this trinomial. My first two positions need to be n to get that n squared. I'm starting to move over too far here. All right, and the last two have to multiply to give me an 8, but eventually combine to negative 6n, so I'm going to need to use a negative and a negative, a 4 and a 2. So n squared minus 2n minus 4n is negative 6n plus 8. All right, now we can apply that zero product property. So one of these three factors must equal 0. So maybe I should make a note of that on here as well. Apply the zero product property. So one of the three factors must equal 0. Either 5n equals 0, n minus 4 equals 0, or n minus 2 equals 0. Solving those, you will get your solution. So divide by 5, we get n equals 0. Add 4, you get n equals 4. And for the last one, add 2, you get n equals 2. So to write my solutions, I'm going to put them in a set. I've got 0, 2, or 4, and they should go in numerical order. 0, 2, 4. There we go. On number 24, we need to again factor out the greatest common factor, which on this one is a k squared. And what would remain is a k squared minus 100. And it still equals 0. So this one again is the difference of two squares pattern. So this one we've got k squared times the quantity k minus 10 times the quantity k plus 10, and it still equals 0. Now that we have it factored completely on the left-hand side there, we can apply the zero product property. So one of these three factors must equal 0 for the product to equal 0. So we get k squared equals 0, k minus 10 equals 0, or k plus 10 equals 0. We need to solve all three of those equations. So for this one, to undo the square, we need to take a square root of both sides. We get k squared, I'm going to put that in another step, k squared equals 0. Take the square root of both sides to undo the square. The square root of a variable squared is the absolute value of that variable. The square root of 0 is 0. And now this again goes back to when you had Mrs. Nelson in class when I was out on paternity leave. The two values that you could plug in here to make this true would be like a 0 and negative 0, but ultimately 0, negative 0, they would simplify to 0. So this one is just k equals 0. This one, if you add 10, you get k equals 10. And this one, if you subtract 10 from both sides, you get k equals negative 10. All right, so your solutions are in numerical order, negative 10, 0, or 10. And that's it. All right, number 25. This one, as I said before, you need to get it equal to 0 so that we can factor and then apply the zero product property. So we're going to subtract 4x from both sides and subtract 4 from both sides, and we get x cubed plus x squared minus 4x minus 4, because we're subtracting them to get them to the other side, and it equals 0. Now that it is a 4-term polynomial and there's no greatest common factor, we're going to factor by grouping. The greatest common factor between the first two terms is an x squared. When I factor out x squared, I have an x plus 1 remaining. Between the next two terms, the greatest common factor is a negative 4. When I factor that out, I have an x plus 1 remaining, and that equals 0. Now they have a greatest common factor of an x plus 1, so factor that out. And what would remain is the x squared minus 4. And it still equals 0. So right here we've got that difference of two squares pattern yet again. So we have x plus 1. I'm going to actually copy that from up here. So it's a very similar process to that problem. So this is the difference of two squares pattern. Keep factoring. So this right here is the difference of two squares. We have to keep factoring that. So this is a squared minus 2 squared, a squared minus b squared. So this is x plus 1 from that first factor. This binomial factors into x minus 2 times the quantity x plus 2, and it still equals 0. So one of these three factors must equal 0. So either x plus 1 equals 0, x minus 2 equals 0, or x plus 2 must equal 0. So that's the zero product property, where one of the three factors must equal 0 if the product is 0. Solving all three, we get x equals negative 1, x equals positive 2, or x equals negative 2. Put them in set notation, least to greatest, negative 2, negative 1, and 2. There we go. All right, just two more to go. Thank you for hanging in there. So number 26. Number 26 is a trinomial, but we have a greatest common factor here. So I see that I've got 2, a 2 here, and then a 144, negative 144. They're all divisible by 2, so I'm going to factor out a 2. I have a t cubed, that's the smallest exponent. This is also divisible by t cubed, and this is divisible by t cubed. So I can factor out 2t cubed. What would remain is a t squared, because 2t cubed times t squared is 2t to the 5th. Remember, multiplying like basis, you add the exponents, so you get the 5 exponent. For the next term, we have t left over when we divide out the 2t cubed. And for the last one, we have a negative 72. We already factored out the t cubed, so that's it. And it still equals 0. Now that we have a trinomial, we can try to factor that. So we have 2t cubed times the product of two binomials, and then it will still equal 0. To get t squared, we need t times t. And then to get negative 72, we've got some options there. So let's think. 72 and 36 aren't going to work to get that t in the middle there. So let's go to 72 and something bigger. 6 and 12 would not work. 14, 72, and 7, 8. 8 and 9. There it is, 8 and 9. So I need to multiply to negative 72, so I'm going to have a positive 9 and a negative 8. Again, practice, 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 and you'll start to see these patterns a little bit easier. So just to double check this, t times t is t squared. The outside gives me a negative 8t, the inside a 9t, that's positive t when you combine those, and then multiply the last two, you get a negative 72. All right, set each one of these equal to 0. 2t cubed equals 0. T plus 9 is 0. Or t minus 8 is 0. Solve all three. On this first one, divide off the 2. And then we need to take a cube root to undo that cube. So the cube root of both sides. Cube root and cube root. That will cancel out the cube. The cube root of 0 is 0 because 0 times 0 times 0 is 0. This one, subtract 9 from both sides, you get t equals negative 9. And the last one, add 8 to both sides, you get t equals 8. So my three solutions in numerical order are negative 9, 0, or 8. All right, on the last question here, number 27. Factor out the greatest common factor, which is 3s. What remains is a 4 minus s squared, which still equals 0. We've got the difference of two squares here, so we need to factor that. So we have 3s This is 2 squared minus s squared, so 2 minus s times the quantity 2 plus s is the factored form, again using the difference of two squares pattern. And now we'll use that zero product property. So one of these three factors must equal 0, either 3s equals 0, 2 minus s equals 0, or 2 plus s must equal 0. All right, solve all three of these. So divide by 3, you get s equals 0. Subtract 2, so negative s equals negative 2, which means s equals positive 2 when you divide by negative 1. Or for the last one, subtract off the 2 and you get s equals negative 2. So your three answers in numerical order are negative 2, 0, or 2. And that is the last answer. If you have questions, please email or call me. I know, again, that this one took a while, so thank you for all your hard work. Keep on going. We're almost to summer. We're below 40 days at this point. Hang in there. Thank you.